Today we are starting 1.2, Introduction to Parent Functions. The main objectives for today, we're going to talk about identifying parent functions from graphs and equations, use parent functions to model real-world data, and make estimates to unknown values. The main vocabulary we're going to talk about is what a parent function is. We can classify numbers into sets based on their common characteristics. We can do the same exact thing with functions. What a parent function is, it's a function that has been broken down to its basic characteristics. Some of our parent functions that we're going to talk about. The first parent function is your constant. A constant is based off from f of x equals c. It is a constant. It's a constant number. When you graph a constant, it is a horizontal line. When we're talking about the domains, does anyone remember what a domain is? The x-coordinates. What this is saying, this symbol right here stands for all real numbers. It's saying I can put any value in here for x and it will work. The same goes the range for y. The only number it ever goes to is whatever c is. It crosses the y-axis at 0, c. A linear function. A linear function is a function of the form f of x equals x. When we graph it, it's a diagonal line. The domain is all real numbers. The range is all real numbers. There are no limitations that you can't graph. The y-intersect is 0, 0. A quadratic function is a function that is in the form of f of x equals x squared. The domain, I can put any x values in here for x. It's all real numbers. The range of the parent function, there are no negative y values. So the range for a quadratic is y is greater than or equal to 0. This one also crosses at 0, 0. The next one is a cubic function. A cubic function is f of x equals x cubed. It's that sideways S-shaped. There are no limitations on your domain and your range. So those are all real numbers. And this, again, crosses the y-axis at 0, 0. And the final one we're going to talk about right now is square root. The square root function starts here and just goes off to the side. There's a reason why there's nothing else over here. Anyone know why? What do you know about square roots? Do you know anything about square roots? What about negatives? Why? What's the square root of 16? 4. 4 times 4 is 16. The square root of 25 is 5. What's the square root of negative 25? 5 times 5 is 25, not negative 5.
You can't have a negative square root.
Can't have a negative. If I multiply two negatives, I get a positive. That is why there's no negatives over here. You can't take a negative square root. So the restrictions on your domain, you have to use positive x values, which means you can only get positive y values. So what we're going to do is we're going to identify the parent function for g from its function rule. Then we're going to graph g on our calculator and describe the transformation that occurs. So if we have g of x equals x minus 3, what's my parent function? What's the most basic form of this function? Not x minus 3 is a function. What would be the parent function? Which one of these does it match up with? It's linear. If we get rid of all the extra numbers that are being add, subtract, multiplying, dividing, you are left with f of x equals x. That is your parent function. Anyone know how to graph? What do I have to hit on a calculator? Y equals. So I press y equals. You see your list of y's. So for y1, we're going to type what we have in there for g of x. Anyone know where the x button is? Next to the alpha. You see x, t, a theta, and an n. Press that, that's your x value. Minus, minus. Do not use the negative. The calculator will think you have an error. And then 3. Now we're going to press enter, and it's going to take us down to y2. And y2, we're going to put just x. Notice when I type something, it is highlighting the equals. When you have something highlighted, it will graph that. If I go all the way up and press enter on there, if this was highlighted, the calculator is going to look to graph whatever's in plot 1. If you're trying to graph something that's not there, it will give you an error. Now, if I go to the second one and go all the way to the left, you're now flashing on that type of line. We want to distinguish the two lines from one another. If I press enter, it changes the solid line to a darker line. If I press enter again, it will shade it above. Press enter again, it will shade it below. Enter again, it has a little line and a circle. This means it will go point by point and draw a line as it goes past. If I press enter again, it just shows a circle. This will just show you the path of the graph. So if I press enter again, it's a dotted line. I want the darker one, so I'll press enter a couple more times. If you have one of the TI-84 Cs, the C stands for color, you will have the option to use a different color for each graph. If you have one of the Inspires, it automatically changes the color between graphs. Now, some of you haven't used the calculator before. You don't know what was done with it. So I want everything standardized. So we just hit zoom 6. That will graph just a standard graph in the standard window. 6. You have your two graphs. The darker one is your parent function. The lighter one is the x minus 3. If you're not sure which one's which, you just can't hit up and down. Up and down just moves the cursor. If you press trace, notice when I press trace, right here it's saying y1 is x minus 3. If I press up, it says y2 is equal to x. What type of transformation has occurred? Now, what type of transformation has occurred? It's a translation. What type of translation? How has it moved? They move up, down, left, right. How did here's the parent function, the first one, the solid one. How did this one move? From the parent function to this one. It moved down. How many did it move down? 3. The way to tell that, right here, I have x minus 3. That tells me there is a vertical translation of negative 3. It's moved down 3. Here's this function. I have g of x equals x squared plus 5. What's our parent function for this one? Quadratic, and a quadratic is x squared. So now we're going to put this one in the calculator. Now you can just hit clear to erase it. That will work. Or you can just delete what you don't need. I want you to type both of those in. All right, putting in the calculator, I'm going to put the parent function in first this time. X. How do I get an exponent? Right here, diagonal to the 7, there's an x squared button. It will square whatever number you put there. It will automatically throw up the 2. Some of you mentioned you need to put this caret. Now, if you have an 83, you'll actually see the caret on your screen. If you see an 84, or if you have an 84, it throws it up as an exponent. Now you just type the number. Problem is, if I keep typing up here, it's going to keep going up there. What you need to do is to get out of being an exponent, press to the right. It'll drop it back down. Now put plus 5. Or sorry, we don't want plus 5 in this one. This one here, I'm just going to go x squared plus 5. So this one I put the parent function as the normal one, the other graph as the darker line. Just by thinking about it, what's going to happen? What type of transformation? What type of transformation?
So y1, the parent function?
y1 is your parent function.
Well, maybe go backwards this time.
For this one, I just put the parent function first, the other one second. This one is a translation of 5 units upwards. And there's your graph. Looking at this one, I have g of x equals negative x squared. I have g of x equals negative x squared. What type of transformation do you think is going to occur? Is it a translation, a reflection, or a stretch compression? Why do you think it's a reflection? All right. How can I tell that something's a translation? Adding or subtracting. Easy way to tell if it's a stretch compression. It's multiplying or dividing. The way to tell a reflection is a negative sign. Usually when you see a negative sign, that means you have a reflection. I want you to put both of these in the calculator and see what happens. Do you get a reflection? Are we noticing anything? All right, the original parent function stays the same. This one here, if I press clear, it clears it out. If I put negative x squared, and I'll make this one darker. And I hit graph. There's the first one. There's the second one. Is it a reflection of one another? When you're thinking of reflection, you're thinking of it going up and down, correct? This one doesn't. It stayed the same. Why do you think it looks the same? Nope. When you square a negative, it becomes positive. So that negative is really not affecting that problem in any way. There is a difference between this one and this one. If I put the second one in the calculator, and I got rid of these parentheses, it's probably going to give me an error. Nope. Because the parentheses aren't there, for this one here, the calculator is saying I want negative x squared. This one here is taking negative whatever x squared is. So it's always going to give you a negative number. That is why that one is a reflection over the x-axis. Questions? Sometimes we don't have an actual function. Sometimes we're given a table. So I have a table with these points. I have negative 2, 12, negative 1, 3, 0, 0, 1, 3, and 2, 12. With only the information that's in the table, we can sort of figure out the behavior of the graph and see if we can find a parent function. You should be able to graph these by hand, but I'm going to show you how to put them in the calculator. So we have these points here, the same ones. I just took them out of the table and put them in the set form. To put these numbers in the calculator, last number is 212. To put them in the calculator, I press the stat button. When I press the stat button, I'm going to press enter. It brings up a list. If your list, or your list should have L1, L2, L3, L4, L5, L6. If it's missing one, the quickest way to get everything back is to reset your calculator. Second plus 712. It's written on the board at all times. L1s are where I'm going to put my X values. L2s are where I'm going to put my Y values. So in L1, I go negative 2, press enter. When you press enter, it automatically drops it down to the next block. Negative 1, 0, 1, 2. That one that's covered up is 212. All I have to do is press to the right, and it starts off for the Y values. My Y values are 12, 3, 0, 3, and 12. If you did it correctly, they should line up. If you have them mismatched, where one side has more numbers than the other, the calculator will give you an error. It's saying mismatch. So get both of these typed into your calculators. Now I have the information in the calculator. In order to graph it, I have to tell the calculator to graph the statistics. Notice above the y equals it says stat plot. If I do second, y equals, it should say all the plots are off. I'm on number 1, so I can either press the number 1 or press enter. I want to turn this plot on. I can move left and right. I want it turned on. Now it's asking what type of graph do you want? We want a line graph. We don't need a histogram or box and whisker. We put our x's in L1, our y's in L2. If you put them in something else, you have to change it here. In order for things to show up on our screen, if I just press graph right now, oops, I have old stuff. If you have more stuff than what you want on your screen, press y equals. I can just turn this off or clear it. Not every point showed up on that screen. If I do zoom, these are the different zooms. Zoom standard just sets it back to a 10 by 10 window. If I go down, there's one called zoom stat. So if you press zoom and then the number 9, it will zoom to your exact statistics. And why did I forget to turn that off again? So there's my points. There's my 5 points. 1, 2, 3, 4, 5. What shape does it take? U shape. It's a parabola. Which one of our parent functions is a parabola? Quadratic. So these points here would form a quadratic. Any questions? Now this example, we're going to graph the relationship in years, or from years to sales of millions of dollars. We're going to figure out what best parent function we could use. So I have the chart. In year 1, they made $0.6 million. Year 2, they made 1.8. Year 3, they made 4.2. Year 4 is 7.8. Year 5 is 12.6. So we're going to find out what parent function best represents this data. Then the second question is, when did they reach about 10 million? Yes, I know you can look at the chart. It happened in between here somewhere. So we go into calculator, stat, edit. You have information in here. You might want to get rid of it. You don't have to get rid of it all, but you can go press up on L1. It's showing this entire set of data that we had from our last problem. If you press clear and enter, it is gone. If you press delete, it's gone. L2 and that. What that means is you now have to put L2 back in there. One of the quickest ways, second plus 7, 1, 2. It's now reset my calculator back to the way it was originally. When I go into stat, edit, L2 is back. Year 1, year 2, year 3, year 4, year 5. Press to the right. Year 1 was 0.6 million. Year 2 is 1.8 million. Year 3 is 4.2 million. 5, 7.8. And 5 is 12.6. I need to turn mine on because I reset my calculator. Second, stat plot, it needs to be on. I'm going to press zoom 9. That will zoom to the statistics. What type of shape do you see? All right, it's going like this, right? It's sort of linear, it's sort of quadratic, maybe linear. It's hard to tell. So the parent function, which one do you want to call it? It's almost a straight line. There's just a couple that are off. So the parent function we'll just call as f of x equals x. When it's 10 million, would it be closer to the 4 or closer to the 5? I mean, looking at these numbers. Or is it right in between? It's probably right in between, so about 4.5 years. Questions on this section?